This video is about concept of volume by integral. Volume by rotating across x-axis. We have a function y equals f of x, which is rotating across x-axis. We will use the disk method to work out the volume. How to remember this formula? Think about this volume is made up of millions of this cylinder, very tiny cylinder. Height is dx. The radius is the y. So the volume of this tiny cylinder, pi r squared h, equals pi times y squared times dx. Then we will use the integral to figure out the total volume formed by rotating across the x-axis. We will use the Washer method to figure out volume formed by two functions. Normally, y2 is the outer function, and y1 is the inner function. Generally speaking, volume by Washer method equals the volume by outer function minus the volume by inner function. Volume by rotating across the y-axis. You can consider this volume is made up of millions of this very tiny cylinder. dy is the height. Radius is x. Then the volume of this very tiny cylinder equals pi r squared h, which is pi times x squared times dy. Then we can use the integral to figure out this total volume. The volume by Washer method equals the volume by outer function minus the volume by inner function. Find the volume of the solid of a revolution generated by rotating the shaded region through 360 degrees about x-axis, which means the volume equals integral pi y squared times dx. Let's figure out this function. Slope equals 2 over 3. So y equals 2 over 3x equals integral pi times 2 over 3x squared dx. It's from 0 to 3. Four over 9 pi. Integral from 0 to 3 x squared dx equals 4 over 9 pi x to the third power over 3 from 0 to 3 equals 4 over 9 times pi times 9 equals 4 pi. Let's go to question 2 about x-axis. For this question, we got to use the Washer method because the shaded area is not connected with this x-axis. This is the outer function. y2 equals 2. This is the inner function. y1 equals 2 over 3x. So volume equals integral from 0 to 3 of y2 squared minus y1 squared dx. Do not forget pi. Plug in, we got take out pi. Pi times integral from 0 to 3. y2 squared is 4 minus 2 over 3x squared dx equals pi times integral of 4 over 9x squared equals 4 over 9 times x to the third power over 3, which is 4 over 27, equals pi times 4x minus 4 over 27 x to the third power from 0 to 3. Plug 3, you will get pi times 12 minus 4 equals 8 pi. Let's go to number 3, about y-axis. Volume equals, about y-axis means dy, pi x squared from 0 to 2. This function y equals 2 over 3x. We need to figure out x equals 3 over 2y. So we get integral from 0 to 2 of pi times 3 over 2y squared dy equals integral from 0 to 2, constant number 9 over 4 pi times y squared dy equals 9 over 4 pi. Integral of y squared is y to the third power over 3 from 0 to 2 equals 9 over 4 pi times 2 to the third power is 8 over 3 reduce equals 6 pi. Let's go to 4. This shaded area is rotating across the y-axis. Since this shaded area is not connected to this y-axis, we got to use the washer method. For washer method, this is x2 equals 3. We already figured out this x1 equals 3 over 2y. Volume equals integral from 0 to 2 of, since rotating about y-axis, this is dy, pi times x2 squared minus x1 squared. Plug in, take out pi times integral from 0 to 2. x2 outer function is 3. 3 squared is 9 minus x1 is the inner function. 3 over 2y squared is 9 over 4y squared dy. Now take out. 9 will be 9y minus 9 over 4 times y to the third power over 3 from 0 to 2 equals pi times 9 times 2 is 18 minus 2 to the third power is 8, reduce 6. So final answer 12 pi.